Hello again. Once more, welcome back to Leopard Street. Welcome to the cellar of dreams and biscuits. Right, today, you may notice there's a bit missing here. This is where I'm going to fit in the second part of wiring up the upper deck and the stations. Now, the last episode, I did the board which is off to my right with all the basic wiring. Now, I'm not showing that again because it'd be exactly the same thing, but more so. So, ta-da, it's done. We'll have a quick look in a sec. What we're doing today is I'm going to be adding, I can get one out, these little beasties. Point servo, well, servo motors. I use them as point servos. I stick them in a little bracket. It's on my Thingiverse site if you need them. I've discovered it when I download some myself, I couldn't find them. For some reason, they print really tiny to start with. And you just need to rescale them to get them to 35mm wide. So, yeah, that's that. Now, I've also got to connect the frog relays, because all the wires are in except all of these. And to that effect, I've got a relay board. We're going to have a little look at all this in a sec. But the goal of today, get this to the point I can run trains. I'm then also going to do the same thing over there. What I'm going to do is I'm going to put the hardware on. I'm going to show setting up one of the points, and then I'm just going to do the rest, because frankly, there's 6 on here. You don't need to see me doing all 6. And there's 1 on there as well, so I've got 7 of them to do. We'll have a look at 1, then we'll get it powered up. As I've mentioned, I'm not fully powering this up today. The servos are going to go in. They're not going to be active. The relay board is going in. It's not going to be active. I'm literally going to be using this to connect the frog wire to one of the DCC rails. I mean, I could just literally connect them to the terminals, but don't want to. I want to do this properly for now, because then when the time comes, I can just plug the board controller in and it should all work. Anyway, so without further ado, on with the show. This is Leopard Street. So here we are with a bit more of a close-up on the implements. So, mounting panel for a relay, 3D printed, fairly straightforward. That just sits on top of there. I was going to stick this on the Thingiverse site. I'm not, because what I found today is, or it's yesterday when I was printing them, is these 8-channel relay boards are not all the same. I printed off the panels I'd used for these things previously, and it didn't fit. I thought, yeah, it's slightly wider, slightly longer, yeah, whatever. Anyway, so what it is, this is 8 single pole, single throw relays. There's a 10-pin connector there. You've got power at one end, ground at the other. I think it's ground that end, power that end. 8 pins that control them. There's a separate header for if you don't want to use the same power, which is how I'm going to wire them up. They're a little bit curious because they're active low. So if you don't apply power to these terminals, but the coils are powered up, the relays will trigger. Yeah, anyway. So I'm going to be putting the frog into the common terminal and the DCC rails going to either side. And I'm just going to set that up so that when there's no power to this whatsoever, the points are set for straight ahead. So that'll run. And we have the little servos. These have all been tested. And if you're going to use these things, test them. Very simple. You just literally plug them into whatever you're going to control them with and make sure they move. These have all then been centered. The code I use to drive the layout responds to thrown and closed for the turnout, so it'll be like that way. It also responds to mid, which puts it in the center. Useful for painting, actually, to set all the points to mid and all the switch rails move into the center position. But it means I can set them up nicely. And we've got the end bits. Like I say, we've got the brackets. And then here, I have a big bag. Let me get one of these out. Of push rods. And they're a little end piece. That sort of fits through the horn, goes into that. Goes through... Yeah, there's a hole in the base of the servo bracket, which by the look of it I'm going to have to drill out because it's not quite done it properly. That's fine. Job done. So, this is where we are now. all nicely wired up. I've got the 5 blocks, all the blues commoned again as usual. These will all be commoned at the end just as a temporary feed thing. They're not at the moment. The frogs are going to obviously connect to whichever of these terminals they need to. So the first thing, let's have a little look, is going to be working out where we put the relay board. So as before, there's a little bit of a conundrum about where this thing gets put. I'm going to make sure I get it the right way round as well. It goes on that way round. So all the frog rails will come into the top. There's 6 frogs here, 8 relays. There's going to be another one of these somewhere. I want to put them near each other. But I've got to watch where they go because I don't want to be drilling things through. And obviously I haven't got the rest of the point work and everything set up on this. So I may end up making these so I can move them. I say down here is going to be where the control system lives. There is, I mean, I've got points coming down. Let me just have a quick glance around, see which, make sure I get this the right way around. Yeah, the rest of the points on this board are going to be that way. So over here will just be power feeds and similar. But as I said, I'd like this to go where the cork is, which I don't think is actually going to be possible this time, so I'm going to have to watch out. But what I'm going to do, I'm going to fit this. I'm going to put it over here. Put it about there, and then there'll be another one over there. I want to leave a bit of space for signals and things to come through. So if I get this panel, I need some screws. And then a screwy driver for this. So I'm just going to just put a couple of screws into this. It's easier just to put the screws in just a little bit to start with. It's also a lot easier to fit this without the relay board fitted to it. Basically because it's a lot lighter. So this is going to go, I'm going to put it, I'll come around here. I'm going to try not to be too much in your way. I'm very aware when I do some of these videos, you can't really see what I'm doing because the only thing in focus tends to be my arm. Yeah, it's not ideal. Screw that in there, not tight. So I can bring that around. You don't have to have them square. I mean, you can do these on any angle you wanted to. But, it helps a little bit with... a phrase I've heard used in software programming is, if it looks right, it is right. And make things that aren't right look wrong. Which is something I approve of as a concept. And if it's right, if it's wrong, you want it to look wrong so that things stand out. So this thing goes in into here. Again, I can just do one to start with. And as I've said, this won't be getting power applied to it today. All that's coming in the future. This is all about, as I've said before, get trains running. The other mounts I've done for this, I printed off in purple, sorry, in grey rather than purple. This one is this is in purple. When I was changing the printers over, I was trying to print some things on the previous one. I was having some problems with it. I've just about run out of the grey I was using. I needed another colour. And because I was printing things I was going to paint, I grabbed the first box that came to hand, and that was purple. So that's why all this is printed in purple now. Because, to be honest, I'm not going to use purple for anything else. So yeah, why not? And there we go. Now, there is one little thing I do need to do before we go in here, and that is change a little bit of how these are labelled up. This is point motor 2. I've labelled this as frog 2. Frog 2 is actually this one. Because it's a double slip, the motor at one end controls the frog at the other end. So I do actually need to change the labelling while I'm here. So I'm going to do that while I remember. So that is actually 3F, and that is 2F, and then I've got the other double slip, which is up here. So frog 4 is actually frog 5, and I've got over here frog 5 is actually frog 4. It's worth sorting that out while you're doing it, because it avoids problems later, shall we say. Right, and I need a different screwdriver for these terminals here. So I'm going to do, are these normal ones or are these cross ones? I think this will take cross. Again, some of these relays want Phillips screws, some of them want flathead screws, which is annoying. But there we go. So I'm just going to back off 6 of these. The relays are labelled, which is also helpful. And what I've gone with is very simple. I've used the channel numbers on the board. So 1 to 8, 1 to 8 there. And I will put relay number 1 onto frog number 1. It's just a simpler way of doing it. What is slightly annoying, frog 1, so relay 1, frog 1, relay 1. When it comes to the code, instead of that being 1 to 8, it's 0 to 7, which is, yeah, I did think about labeling them like that, but to be honest, I've got too far in the layout now. If I start labeling things that way, I'm going to cause myself no end of confusion with most things. I know 1 is 0 and so on and so forth. If I start having it applies like that on some boards but not on others, I'm going to cause problems. Right, the next thing is to terminate the frog wires. That's the easy bit. And for that, one of these and the good old bootlace ferules. So let's have a little look. This is number 5. And again, I've got to keep clear of where the point motors are going to go. I mean, in theory, I probably should put them on first, but it sort of doesn't matter which way around you do it. I'm going to grab a cable clip. Probably actually going to fit 2, but this will do for now. Because I want something that I can use to hold these wires sort of out of the way a little bit. So I put one here, up here a little bit further. I'm going to put one there. I'm going to put another one over here. These are just going to hold wires, so it isn't just neatness in this case, although there is a little bit of that. The main reason for doing this is these wires can't hang down more than 2 inches. So basically, I want them within the framing, and they are more or less within the framing. They hang down a little bit, because if they hang down too far, they're going to catch on the trains running underneath. So if I put... Come on, bite. There we go. If I put some of these in, I can put cable clips in, and I can hold it out of the way. If it ends up as a real problem, what I'll do is I'll take this board out, and I'll basically put the wires down. I'll just hot glue them, and that'll hold them. Right, so this one is going to go into relay number 5. So this is the other thing. When you're doing this and you don't want wires hanging down, you don't want to make them too long. You don't want to come too short. One of the commenters, Rodney25, I think his name is, or 52, one or the other. I apologise for getting that wrong, because I know I've just got that wrong. As sort of noted about, leave wires a little bit long. So if you make a mistake, it's not a terminal mistake, because what you can do is then, I'll just recut it. This is an extremely valid point. It is well worth keeping in mind. You don't want them too long, because here they'll dangle down. If you've got a bit more space, having wires longer actually isn't a bad idea. So that's going to come down there. That is frog 5, so it's going to go into that one. Now on all the other boards, these are slightly easier to get at because obviously they sit on drop-down panels, which were dedicated electrical panels. Whereas this board here doesn't have a dedicated electrical panel, so yeah. Let's just put a tie wrap in here, and then I can use that to hold these wires slightly. I'll just feed the others through it. Let's do that. And unlike some of the others, this one I am going to cut because it's never going to be a tight one. There's no point making them tight. It won't go tight enough down onto these cables. These here, like, I mean, these could do with being held down there. But as you see, I can sort of... That may need something else to hold it. But we'll see. Right. Carry on with that. This one here is... if I take this one up here. This is number 4. Which is going to go through this side here. So it is going to be routed a little bit further down. It can't go straight across because there's a hole there, which means there's going to be a point motor there. So that's going to go round there, round there. It's going to go down there into number 4. So if I do that to there, again, it's round, and in we go. So I'm going to get the rest of these green wires done. Then we'll be back when we look at how I do the other ones. See you in a moment. Here we are in a slightly more confined space, hence why we zoomed in. Right, the next thing I need to do, I've got the green wires done, we'll have a look in a sec, is work out what the frog wires need to connect to. So all of the points, I'm going to have this set. So this line runs straight through. This line runs straight through. This one runs straight through. This one runs straight through. Because as I say, I'm not powering the servos up yet. So this frog needs to connect to this rail here, which is a brown rail. The brown feed there. So I've made a note that 0.6, the frog needs to connect to brown. Down here, this is point motor 4, so this is frog 4. Remember, it's at the other end. So frog 4 needs to connect to the upper rail, which is blue. Point motor 5, frog 5, to connect to the other rail, which is brown. Easy with double slips, they're always going to be opposite. Point number 1 is here, connect straight through. This connects, so this rail, this frog bit needs to connect to this rail here, which is brown. And then the same down here. So, I just put you back over here. Right, so with that determined, the other thing I've made a note of is, so for example, up here, frog 6, which is 0.6, which is the motor which is over there. Frog 6 is a brown wire, so it needs to, so the relay down here is going to need to connect to the brown side, but it needs to connect to brown 5 because it's got to be part of the same block detection system. So I've put this commoning rail in because obviously they're all going to be common for now. But what I need to do is feed that, and it's going to go into the top. It'll just be another connector that goes into there, but it'll come down here and go into this. All the blue ones will be commons together. They'll come over here. It'll be a bit of a mess. Some of the other boards, this is a lot more cramped, so it's like a really short wire that just goes like that. Here it's a bit further. Might actually help. So what I need to do is find where I've put, here we are, where I've put the 2 coils of wire. That'd be a good help, wouldn't it? Right, so let's have a little look. Incidentally, I can't really zoom in on this. The camera I'm using, it's an iPhone. I'm using the forward-facing camera for this, so I can see what's in shot. Unfortunately, I don't think you can zoom that one. If anybody knows otherwise, please let me know. Right, it's not that I need. It's, oh, it is that I need in a minute. I need my roll of ferrules. I'm going to need both crimping tools, screwdrivers and other bits and pieces to do this. So the first thing I'm going to do is I'm going to connect the blue terminals. There's only actually 2 of them. Well, 2 of the unpowered ones. So now we need the multimeter. Because at the moment, I have to say, I don't actually know which way around these are. So what we've got is a common in there, and it connects to one side or the other. So it connects to that side. So this side here, in the case of this one, this is number one. I'm going to do these in order because it makes life a little bit simpler. So number one connects to brown one. So I need a length of brown wire, which I've got here. And this is going to need one of these ferrules put in on one end of it, and it's going to need a fork terminal on the other. And this is the only one that's connecting into brown one. In fact, all of these wires actually connect to different sections, which is quite useful. Sometimes you've got points in the same section. A lot of the early part of the layout actually it is exactly that. They're like the point fans for the fiddle yard are actually all part of the same section. So that sort of helps. So that's going to go into there. I'm not going to fix it in just yet because I'm going to need to bring it out, and it's going to come out. It's going to run along here. I've got to bypass all of that because it's going in the top, and it's going to go to there. So again, slightly longer than it needs to be wherever I put the cutters. And then this wants a fork terminal adding. So because it's a single wire, it's cut it a little bit long, twist it. They say that I've seen various guys that say you should never twist these when you're putting them into crimp terminals. Yeah, I sort of agree with it. The problem is I find you can't get the wire into the damn terminal if you don't. So yeah, and then so the other thing actually with these, if you notice the jaws are different. One's smaller than the other. The small jaw goes above. If you do it the other way around, it doesn't crimp properly and the wire falls out. As I learned that one via experience. Yeah, it's bitter experience. There's a sort of sad, bitter, twisted, and so on and so forth. Right, so this here is number one. Slacken that off. This goes in, and it's going to have to go in backwards because it's going in behind the other wire. So that goes in. Get the thing not to try and twist itself around while I'm holding it. So that will be helpful. So that goes in there. Now, obviously, if you're not using the block detection and you have no intention of ever using block detection, you don't need to do half of this. I mean, yes, you'd need these point relays, but you'd just have all of this would just be a common bus, and it would all just be connected to that. So this can come across here behind. Right. This is where it doesn't matter as such, but it's sometimes nice to have, if a piece of wire is behind something in one place, is have it behind that thing elsewhere. So like there, these wires come in front of these, so I'm going to route this one in front of them as well. It's going to come down here like so, and is going to connect into this one here. So open that out a bit, twist that round in, and then like that. And what that should now mean is frog number one is connected to the brown wire, but it's only connected to the brown wire at the moment. I don't actually need to put the other terminals in yet because they're not going to be used, but I'm going to, because once they're in. I can forget about them. So anyway, let's just have a quick look around the other side of the board, and we'll see if that is actually correct, because it should be. So I'm just going to move this out again a little bit. Come for a ride. Hello. And try and find somewhere to put you. Sit you there. Is that going to work? Point number one. Point number one is it's always the way with cameras. Anyway, never mind. Right, point number one is here. So this frog should be connected. This is layer one as well, so it should all connect together. And if it is, what this means is when I power the layout up, I'll be able to drive trains on it, which is the idea. So if I set that to there, okay, let me just make sure I've got this correct. So that is on there, connects to there, connects to there. It's all the frog rails connected, not connected to that. So a train coming along here, you can see with the power, that works. And obviously this other rail here, just for the sake of simplicity, that works. And this blue rail is connected to this bit up to that insulating join. So what that means is that point is now correct for this system has no power, which is where we are at the moment because I've not powered it up. So let me just move this back across here and we'll go back to the other side like so. Yeah, come back around here for another ride. It's always good, this riding things when you're doing train stuff. So that can stay there. What I now need to do is connect the blue terminal over here, but I'm going to do two blue ones at once. So I'm going to do all the browns first because all the blues can be connected. So the next one, relay 2, that needs to connect to brown 3. So again, I shall start off with this end. Yeah. Now, fairly obviously, it doesn't matter which end of the wire you strip and do first. It's literally, you can do either of them until you've fitted it. It doesn't matter. What you may find is sometimes it's easier to fit one end and actually install it, then run the wire through. It depends what you're doing. So that's going to go into there. That's then going to come along here up to the top. And it's going to go down like that into brown 3. So I'm going to cut that there and do another one of these. Now for the points, I don't actually have to fit the servos today if I don't want to. The points have still got springs in, so they will stay where they are put. I do need to fit it for the slips because obviously I took the springs out as part of the modification process for them. So in practice, what I'm going to do is fit all of the servos. This is something, I mean, we'll come on to it in a minute. It's one of these things that you think, oh, you could batch wire these. So this is, let me just check. Number 2 is going to brown 3, which is this one. This suggests actually 2 doesn't have. It's feed number 2. Yeah, I was just looking at this thinking that's a bit odd. Yeah, no, feed number 2 doesn't actually have any points attached to it, which is why none of these are going to that one. So that can go into there. Again, tighten it up. Yeah, as I was saying, with points, you start thinking you can batch do certain things like cut all of the actuator arms to the same length because they should all be the same length. And you're right, they should all be the same length. Place your bets on whether they will be, because they won't be. They all want to be fettled just slightly. And because they all want to be fettled just slightly, your best bet is do them individually. And then they'll be fine. Right, so I need to, down here, back out that terminal. Let's go down here. Something to be aware of, you may have spotted here. You can get electrical interference here. All of these wires I'm fitting at the moment are carrying DCC signals. So you may think, oh, well, that's not very good. And in many ways, you'd be right. There are problems with that. But it's a fairly robust system, the DCC system. It can cope with a fair bit of interference. I mean, you could start doing twisted pair, you could start doing shielding. If you don't need to, don't bother. Right, relays 3 and 4 need to go to blue, so I'll do those in a minute. So relay 5 goes to brown 4. So again, let's do this. Where are we? I'm going to do a few of these, and then we're just going to cut away, and I'm going to finish it, and then we will be back. Because as I said before, you don't really need to see me doing all of this. It's really just... It's quite a mechanical process. It's a little bit tedious doing it. I'm aware some of the wiring videos don't go brilliantly. People quite understandably just switch off. So, yeah, so that's there. That's going to go over to brown 4, which is there to that one. So about there. But it's one of these things. If you're gonna have a model railway, you're gonna have to get used to doing a bit of wiring and playing with wire. It's just one of those things. They say DCC is just 2 wires. I say it's just 2 wires. They're just cut into many, many individual lengths. Yeah, it's just one of those things. But if you're not doing block control because you're not interested in automating anything, it's easy. When I come on to, we're going to have a video at some point about block control and how I've designed the blocks here. What you'll see is you don't need to block wire your entire layout to get the benefit. And to a level, even if you're doing a DC layout, actually you can get quite a bit of the benefit of block control, or block detection, block occupancy detection rather, without actually too much work. Because you just look at it and think, well, where do I actually need this? I mean, I'm wiring it all because I'm going to be automating stuff. But if you're not automating stuff, you don't need to wire it all. And little secret is, depending on how you're automating it, you don't necessarily need to wire it all either. My custom system that I'm sort of developing, that I'm using on this layout, uses trigger points. And this is nothing to do with Only Fools and Horses. This is if a decision will be made based on information available at a given time. So, say I need to change a point or change a signal. Well, I'll have a sensor where I need to know that. And then the train will go past and it'll do whatever it needs to. I don't need to censor the entire layout. Bits that, when no decision is going to be made, don't need to be wired. Right, next one is brown 5, which is this, which is going to go over there. So that's going to be from there, along there, into there. That'll do. Drop that. So yeah, so I can have gaps. At the moment, for example, my reversing loops are not fully wired onto the block detection system. It doesn't matter. The auto system can cope, because the bit in the middle where there's no knowledge of is there a train here or not, no decision is being made. So that bit of information you don't need. It's one of these things you have to think about what you're trying to do with it, because all occupancy detection is doing is giving you information, and what you need to think of, because what that information is depends on what sort of sensors you want to use. If, for example, you just need to know a train is there, you can use current detection with DCC. You could use infrared beam detection. There's lots of different ways of doing it. And it'll say, yeah, there's a train here. But before you do it, ask yourself a question. A very simple question. What am I going to do with that knowledge? Because a lot of the time, what you'll find is the answer is, well, nothing. I'm going to change a light on a status panel. Well, you're going to look at that light before you make a decision. Well, not really, no. You don't need the block detection there, do you? It's used in the real world because the signaler in the modern day, can't see the layout, can't see the track. Well, it's your toy train set. There's a pretty good chance you can see it. And there's a pretty good chance you're going to look at the thing and make the decision rather than look at the screen. Because let's face it, looking at the model railway, I mean, you've spent a lot of time and effort and money building the thing. You might as well at least look at it occasionally. So, yeah. So you can argue that actually in that situation, it's not giving you any extra information, so don't bother. The station here, for example, it's going to get block detected, but it's not getting it immediately. Because in the short term, as Kelly has pointed out in many occasions, drive it manually, because automation can go wrong. And it can. Ping in the background. My dehumidifier has filled its little tank. Bless it. So that's good. Right. That's all the brown wires. I've now got the blue wires to go in. Well, I'd say it's all the brown wires. It's not all the brown wires. These do need to go to specific blocks later. Think about it. I think I am actually going to leave off the other channels for now. I'm just going to put the blue ones in on here where I need them. Reason being, I'm going to have to take this apart again anyway, or at least it's going to be on its back again anyway when I fit all the control gubbins. So I can do that wiring when I do the control gubbins, because at the moment I don't need it. To change a point, I'd need to have something that can control the servo and something that can tell the relay change. So yeah. Yeah, I also need to, I'd need to work out which, for the two in the middle, I need to work out which one the browns go to and other bits and pieces like that. So it's just easier not to at the minute. So yeah, this is half a job. Yeah, that is not half a job, but there we go. Never mind. Now this one is going to be slightly different because these blue wires all common together. So what I'm going to do is run a blue. I'm going to run both blues and then I'm going to crimp them into the same crimp, if that makes sense. We'll see very shortly. And we shall do that. It just saves on screw terminals, basically. There's only so many channels on these terminals I can do. So that one's going to go into there. That's going to come across all the way along here to up here, like so. And the other one's going to run alongside it. So what I'm actually going to do is make it the same length, because why not? So do that down there like that, clip. Right, that's the blue wire dealt with. And with this done, in theory, a chunk of this can power up. Now in practice it can't because I've got to put the servos in. Again, only on the slips, but I'm going to do it for the whole layout, or the whole board rather. That is worth doing in one go because it's a bit awkward. So do that there, like so. I'm going to put a fork terminal on the other end. So it's going to be tasty, tasty wire. Yay! So there we go. Yes, sometimes it's you get some of this wire and you see it's listed as pre-tinned copper. And you sort of think, so you've done something that I can't check, and you're saying it's copper when copper's more valuable. In many cases, I suspect it's not actually copper. Some of the decent stuff will be. Some of the cheap stuff won't be. This will be, because this came from Farnell, so this will be decent stuff. Right, so come over here, and I'm going to use that one. It's only got one in it at the moment, so I shall use this. Reason being, I'm going to have to do 4 more wires to do the off channels of the brown ones. So what I'm going to do is get that. Take that out. Put that one in first. Put that one in on top of it. There we go. That works. Out. I'll just get it to bite it, and then once it's bitten it, I can safely move over. So I can then come around here, in here, under that brown wire, because that's where all the other blue wires are going. Under that brown wire. under there, through here, that, helping hold it in place, through this one the same. This is, you see why I didn't tighten this one up too tightly. It's got quite a lot of wire going through it now. This comes down here. Now they're into 3 and 4, so it actually comes this way. Down here. And one is into that one. One is into that one. Tighten those up. And then back to the other side of the board because I need to test this. So I'm going to get that done. I'm going to get this tested. I'm going to come back and we're going to put the servos in because you've seen me do wiring now. All right, back in a mo. Yeah, so this is now editing me. Now I've decided I'm going to end this particular video here before we jump into the next section with the servos. Otherwise, this is going to be multiple hours long, and I think that's just a little bit too much. So that's going to be it for this episode. Usual likes, comments, shares, yada yada yada, more than welcome. I will catch you all in the next one where we're going to stick the point servos into this. And then at some point, depending how long that one is, we're going to run into actually driving a few trains, because that'd be nice. Anyway, I'll catch you in a bit.